All right, 7 o'clock here in Sydney, so let's get started, shall we? Hello, everyone. Thanks for joining this Teams Fest spring session on ensuring voice quality and video quality in Microsoft Teams. Probably a bit of a hot topic at the moment, considering now that adoption in Microsoft Teams has increased quite literally by the millions in the last couple of weeks. I don't know about you guys, but I have gotten a lot of questions about how do I set my network up? How do I provide a better service to my end users? Now, just a couple of things before we get started. Please try and keep yourself muted throughout the session. We do have a moderator in here as well, I believe, who will step in and mute you, obviously, if we need to. Most people are pretty well behaved though, so do try and keep yourself muted. If you do want to ask a question at any time, feel free to unmute yourself and jump in, or just type something into the chat if you wish. I'm going to glance at the chat every now and again as I go, and I'll try and pause as I go as well, just in case anyone has any questions. All right, shall we get started? So, why does networking matter? Why do we even need to worry about potentially a switch or an internet connection or a 4G hub that you've given to one of your users? Why does any of that stuff matter, right? Well, the truth is there's three main reasons. The first one being, and it goes without saying, right, but a poor quality network will lead to poor quality Teams calls. Sounds pretty obvious, right? But you try explaining to an end user, hey, if you try and make a Teams call in a moving car on a freeway in poor coverage area with, on 2G or 3G, you're going to have a bad time. So we need to ensure that the quality of the network that the user is using to make the call in the first place is as good as it can possibly be. Secondly, users remember their experiences. Have a think about the last time you used a piece of technology for the first time and it didn't go to plan, or at least it didn't work the way that you expected it to work. How did you feel? How did it make you feel about the technology? Did you want to potentially give it another go, or would you potentially find another solution or another piece of technology to do what you're trying to do? And of course, users have lots of options these days. Think about how many different video calling apps there are. I mean, there's more that can fit on one hand, right? Like WhatsApp, Facebook Messenger, Zoom, Teams. The list is almost endless. Users have choices. You have to ensure that your option works first time, every time, and works flawlessly. Because if it doesn't, the user is going to choose a different option that works for them, the option that has the least amount of resistance to get the job done that they are trying to achieve. Because at the end of the day, everyone has a limited amount of time to get their job done, right? And so if they can call someone on WhatsApp or Facebook Messenger to get a quick answer, that's probably what they'll do. So we want to make sure that the option we give them works well the first time, every single time. How do we do that? Well, we need to exercise some control over the bits and pieces of our network. Now, this is kind of a simplified overview of how a network works, right? But typically, we've got our end users, like people like me and people like you. They are probably connected to some kind of network which inevitably connects across the internet. That's an old school GIF right there. And inevitably, that ends up talking to Office 365, which is where Microsoft Teams is hosted. Of course, in an ideal world, we'd love to have control over all three of those modalities. But the reality is, of course, we probably can only exercise control over these two here, end users and some portion of the internet. The moment the traffic leaves our boundary, hits the internet and goes up to Office 365, we've kind of lost control over it. Again, we can't provide QoS or guarantees once that traffic hits the internet, right? So we need to focus our areas and what we're willing to control against our end users and potentially our internet connections as well. How do we do that? Well, there's certain areas that we can look at that we can potentially control in quotation marks. When we look at an end user, of course, right now we're giving users laptops, or even some users are even walking home with desktop PCs and monitors from the office so that they can work from home. But we sort of have control over what kind of device that end user is using, right? It's probably going to be a laptop that we've either provided to them, or that they've gone out and purchased themselves, or maybe a mobile device, like, like an iPhone or a Samsung or a Google Pixel, those kinds of things, right? So we kind of know what we're working with, maybe an iPad. Of course, we can control the advice that we give them as well. So that could be anything from, hey, when you're making a Teams call, try and sit in a quiet area that has good Wi-Fi coverage, as opposed to a coffee shop with poor Wi-Fi coverage, for example. Or, hey, when you're joining that 10 a.m. board meeting, maybe ask the kids not to play games on Wi-Fi, or if they absolutely have to, or if you've got other people in the household who need to join calls at the same time, maybe use something like this instead, which is a little 4G dongle, right? So we have control over the advice that we give the end user. Of course, it's up to the end user at the end of the day whether they accept that advice or not, but we can control exactly what we give them. When it comes to our corporate network, we have many, many different things that we can control. We can control how the traffic is routed within or routed if you're from the UK. We say routed in Australia. How the traffic is routed throughout your corporate network. We have control over the wireless access points. We have control over how much bandwidth each available user has, the coverage. We can control firewall rules. We've got proxies where we can say, hey, traffic is allowed here, but not allowed here. Hopefully we're bypassing proxies though, more on that later. If you're lucky enough to have things like packet shapers in your environment, again, there is a level of control there about how much data can go across those WAN links. And of course, we do potentially have control over competing services in the corporate landscape as well. I mean, we can step in and say, hey, we're not going to allow Zoom to be installed on our corporate laptops, for example, or we're not going to allow Google Hangout or Facebook Chat. We're only going to allow Microsoft Teams. Again, with an end user device, we may not have that control, but in the corporate landscape, potentially. And of course, when we're talking about the internet, we're potentially looking at two things. So number one is available bandwidth, right? So we can pay more to our internet service provider who can give us more juice, more bandwidth, and potentially control reliability as well. So we can install, obviously not in one day by the snap of our fingers or a wave of a magic wand, but we can install additional internet connections. We can roll out 4G modems, for example. We have options there. Of course, there are a few things that we do not have control over. In an ideal world, of course, we'd be able to say, hey, we can control everything here, and that's how we guarantee our team service. But the reality is, and we're seeing more and more of this now with people working from home, we don't have control over home Wi-Fi networks. We don't have control over who end users pick as their internet service provider, what plan they choose. They may only buy the super cheap plan that gives them very low bandwidth and very low reliability. We can't control traffic that leaves our network either. I've talked about it before. Once it hits the internet, it's outside of our control. Of course, with that advice that we can give the end user about what Teams device to use, the user, of course, can just decide, hey, I don't like the headset that I've been given. I'm not going to use that. I'm just going to plug my iPhone headphones into my laptop, or I'm going to go to Officeworks and buy myself a new headset. Sure, it's not going to be Teams certified, so the experience might not be great, but in their mind, they've solved the problem for themselves. And of course, training, something that's often overlooked, right? If a person chooses not to attend training, that's kind of on them. Teams is pretty self-explanatory these days. I mean, at the end of the day, most of the functionalities and features in Teams, people can probably work out for themselves, but a lot of people out there need that additional training, not only to show them how the technology works, but why also they should use it as well, as opposed to sending an email or writing a letter or sending a fax. If anyone still sends faxes out there, send a message in the chat window if you still send or receive faxes out there. But it's up to the end user if they choose to not attend training at the end of the day. Now, in terms of good versus poor scenarios when we're talking about using and making Teams calls. We have the gold standard. We have a user that's using a fantastic high-powered laptop that's on a high-speed, low-latency network. They're using a certified Teams headset, like this one, for example, or or one of these, for example. Certified Teams device that we know works well with Teams. It has echo cancellation and suppression built into it, and the user's trained to use Teams. They understand how Teams works. They understand what the application can do. They understand where and when they should use it. Perfect scenario, right? Wouldn't it be amazing if everyone was trained exactly that way? Everyone had the right headset. Everyone had amazing internet. That would be a perfect world. We don't live in a perfect world, though, right? So we've got to deal with. We've got to handle what we're dealt with. So we're looking at people on slow, poorly configured, congested networks, typical Wi-Fi networks at home where people are still connecting to the 2.4 gigahertz network that is congested. In my house here at the moment, I've got about 20 different items like light bulbs, smart plugs, TVs, Xboxes. They all talk to my router on the 2.4 gig network. That network is so congested, right? So if people have not configured their IT properly, they're all kind of stuck on that 2.4 gigahertz network, which means they're probably having a poor experience. And if they're not using a certified Teams headset, they're probably having an even worse experience. And if they haven't been trained, they probably think Teams is rubbish. They're like, oh, what is this rubbish? It doesn't work properly. The fact is, we haven't trained them properly. We're not giving them the right tools. But from their point of view, from their point of view, Teams is rubbish, right? And that's what we're trying to solve here. I've just noticed a couple of questions come through. Very, very true about, so Emmy asked a question about using VPN with Teams. In the short version, don't. I've got a slide on that later on that actually covers that off and explains sort of why we don't want to put Teams traffic down a VPN. So more on that a little bit later. All right, let's talk about Teams networking requirements. So some of you may already have seen this, but it's important to point out Teams is relatively bandwidth friendly at the end of the day. So you can see that a peer-to-peer audio call is 30 kilobits per second. That's hardly anything in today's standards, right? Hardly anything at all. Of course, once you start using screen sharing or HD video, the available bandwidth or required bandwidth starts to jump up, right? So we're looking at between 1.2 and 1.5 megabits per second for high quality video. Of course, if you only got a few people using a home Wi-Fi network or office network at the moment to do those high quality calls, that's no worries. But once you have thousands of people within a corporate environment trying to make HD peer-to-peer Teams calls all at once, you got to think about how you're going to manage that traffic, and can your network support that amount of traffic? There are some things you need to configure in your environment as well. Now, this goes without saying, but you'd be surprised the number of people that don't configure their firewalls properly to support Teams. Now, Teams is awesome when it comes to firewall port requirements. Back in the old days with Skype, you used to have massive amounts of ports that would need to be opened up, especially if you're looking at running Skype for Business on premises. Those edge servers, I would spend hours of my weeks explaining to security teams what each of those ports meant and what they did, right? Now, in the world of Teams, we only need to worry about these ports here. So TCP 80 and 443 and UDP 3478 to 3481 from the client to the internet. Now, if you work in one of those environments where your security engineer, security teams say, hey, we actually need you to provide all the IP addresses or the exact IP address ranges and FQDNs, if you're using one of those fancy layer 7 firewalls, check out that link there, aka.ms/office365 IPs. That lists all of the IP addresses and FQDNs that you need to configure within your firewall to allow your clients internally to talk to Office 365. Very important you do that, because if you don't, and you've got a firewall and an overzealous security engineer, people are going to start having problems with Teams. Audio and video isn't going to work the way that it's been designed to work. Someone mentioned it before as well, but proxy servers, even though proxy servers are supported, so if you have a proxy server and you call Microsoft support today and you say, hey, we're having problems running traffic through our proxy servers to Office 365, they'll say, sure, no worries, we can look at that for you. Now, proxy servers are supported, but they're not recommended. Now, the reason they're not recommended is proxy servers are not designed to carry the enormous amount of additional traffic that Teams would generate in your environment. Outlook will do something similar too. Outlook creates several connections to Office 365 to Exchange Online to allow Outlook to work properly, to receive mail, etc. Microsoft Teams is the same. So imagine a scenario where you're pumping thousands of connections through your proxy server to access Teams, not only for chat and IM and team participation, but for video and voice as well. Really, really bad idea. Unless, of course, you've got one of those brand new shiny proxy servers that says, hey, I'm supported and I will work with Office 365, go for it. But most of us don't. So where possible, route that traffic around your proxy server. Someone that just mentioned as well that aka.ms/Office 365 IPs has been taken down. That's a shame. I will double check that link at the end and I will make sure that that works for you. One thing to note on that page, though, if you just put into a search Office 365 ports and protocols, at the top of that page at the moment, there's an announcement that says, hey, by the way, we are pausing updates to the Office 365 FQDN and IP address list. So those of you that are already aware, Microsoft publishes updates to that about once a month, every second or third Tuesday, I believe. And you can subscribe to that page via RSS to receive those updates so that you can keep your firewalls up to date with all of the IP addresses and FQDNs. Microsoft are pausing that at the moment because obviously they realize that a lot of businesses are running on skeleton staff and have no access to any of this equipment. So they paused that update for the moment, which is good news. Do keep an eye on that page, though, if you are using those particular firewall rules. It's very important you check it at least once a month. Someone also mentioned it before. Please don't send Teams traffic down a VPN. Why? Well, a number of reasons. First of all, VPNs were never designed for real-time media, audio and video, never designed for that. VPNs encrypt traffic. Teams traffic is already encrypted, so it's being encrypted twice and then decrypted twice at the other end, which causes delays and latency. Not only that, but you're also putting pressure on the VPN equipment at the other end, and then you're also putting pressure on the corporate network that sits on the end of your VPN network, where you're routing all of that traffic out of your corporate internet connection. Really, really bad idea. The best thing to do is set up split tunneling with VPN. So just chuck into a search term, Microsoft Teams split tunneling. That'll bring up the details. It will explain to you why sending Teams traffic down a VPN is such a terrible idea, why you shouldn't do it. Please, please, please don't do it. Definitely don't do it. And we'll explain to you how to configure your VPN setup to send that traffic out the local user's internet connection straight to Office 365. And just on that, it is very, very, very important that your clients can perform local external DNS lookups. Emphasis on local and emphasis on external DNS. Two reasons. Number one, if I'm a user who's sat in Sydney and for some reason my computer is configured to look up DNS in China or Singapore, for example, Microsoft's Edge network will return the point of presence in China or Singapore, and then my Teams client or my Outlook client will try and connect to that point of presence, as opposed to the point of presence that exists here in Sydney. That's increased latency, increased jitter, problems, basically. Secondly, it's important that your clients can look up local DNS and external DNS as well. So I explained before why they need to look up local. They need to look up external DNS records as well, because Microsoft make changes to these DNS records sometimes. So it's important that your clients don't look internally to resolve these Office 365 DNS records. Make sure they're looking at their own ISP's DNS servers, or just use Google's if you like, 8.8.8.8 or 8.8.4.4, for example. And lastly, try to avoid hairpins in your network. So if you've got sites such as branch offices, or again, users who are using VPNs, that traffic is going to be routed down their ISP to your corporate network and then out your corporate network to the Microsoft network. We see problems like this all the time where users say, sit over in Perth, for example, which is 4,000 kilometers west of here, where I'm sat now. Those users are in a branch office. They're connected to the corporate network, which sits in a data center in Sydney, and they try and access Office 365 services, and they end up coming through the corporate network in Sydney and out the corporate internet, as opposed to accessing the point of presence in Perth. The idea is to get to Microsoft's network, their point of presence, as quickly as possible. So where possible, make sure that traffic accesses a local internet breakout. Don't be pumping that traffic through your corporate network. Now, how do we test that? Well, Microsoft have produced an awesome tool. If you haven't seen this tool before, go check it out. It's connectivity.office.com, and I'll just post that in the chat here as well, so you guys can see that too, and you can play around with it whilst I'm talking about it. So how this tool works, what you want to do is enter your current location in this box here. So I've just said I'm in Sydney, and the tool will show you where the points of presence are in your country and near you. So you can see here right now that if I just zoom in a little bit here, you can see there's me there, that little gray person icon, and the little flag here, which shows Microsoft has a point of presence exactly there. They also have one here in Melbourne as well. If I scroll down a bit, I can see that this tool has tested my connection and has rated my connection, saying, hey, your configuration has been configured the best. You don't want to see yourself down here in the below average or average, and you certainly don't want to see yourself down here in worst. What you also don't want to see when you run this test is that your user actually, it seems to exist somewhere like over here, for example, or even worse, somewhere in a different country. That means that your computer thinks DNS-wise that it's in a different country, and so it's going to talk to a different Microsoft POP. Additional latency, additional round trip times. You can also run a detailed scan as well by hitting the detail button here. This will give you a wealth of information explaining which POP you're connecting to, the DNS that's being used, your tenant name, that's my tenant name there, which edge you're talking to regarding the Microsoft Edge network, if any errors have been detected, your round trip time, packet loss, a whole wealth of information there, right? And it'll also show a trace route from your environment to Office 365 Edge network. So you can see here that I've managed to hit Microsoft's Edge network within 4 hops. That's my internal router. That's TPG, and then Microsoft. So really, really quickly, I'm within the Microsoft network within latency of 12 milliseconds from where I'm sat right here. Really, really good scenario. If you see high latency times here, you need to check to make sure that the DNS on your machine is configured properly. Okay. All right, I'll just move this around so I can see what I'm doing. All right, if nobody has any questions about that so far, let's talk about the Teams end user experience, and particularly how Teams helps the end user deal with problems that may occur. Firstly, Teams, we get a lot of questions about this. So I went to Ignite last year in Orlando. Leave a message in the chat if you were at Ignite in Orlando last year too. A lot of people came up to me in the hub and said, hey, Craig, can you explain to me how Teams is built, and is it Skype 2.0? Like, has it been built on the Skype framework? The answer to that, in short, is no. It's been designed completely from the ground up, from scratch, and it's built and optimized using Windows Azure Media Services to deliver that enterprise-grade audio video sharing services. Most importantly, and what I found really particularly impressive, was that Azure's network has been built with a goal in mind to be within 30 milliseconds of the last mile of the user. Now that is vitally important, because when we're dealing with real-time audio and media, we all know that increased latency causes problems during phone calls. 75 milliseconds of latency is enough to be noticed. That's enough for people to start talking over the top of each other. I'm sure many of you have been in conference calls where someone has said something and then you've started talking, and then you're like, oh, sorry, you go ahead. But they've also said, oh, sorry, you go ahead. And before you know it, you spend 5 or 6 moments of figuring out who's trying to talk, right? 150 milliseconds is where real problems start occurring. That's when it's really noticeable to an end user. That's when they start saying, hold on a minute, I'm actually noticing that there is a delay here. So the closer that the Azure Edge network can be to an end user, and that's where those Teams media services sit, the better end user experience your users and yourself are going to get. So how does Teams help with this? Well, first of all, there's some smarts built into Teams. First of all, Teams will notify you or an end user that a poor network has been detected. So it'll flash up a notification and give you a little red exclamation mark. I'm sure everyone's seen this already. And it'll say, hey, we've noticed that your Wi-Fi connection or your network is generating poor call quality, poor audio quality. We recommend that you move closer to a wireless access point, or we recommend that you turn video off. Some of you may be asking, well, that's great, Craig, but how on earth does Teams decide that that the audio is poor? You know, is someone sat there listening to my call going, oh no, that doesn't sound quite right? Of course not. No one sat there listening to it, right? It's all done using Azure AI. These are the metrics that Azure uses to work out if a call should be classed as poor. So these are the ones that apply to audio. There are a whole bunch of them that apply to video, screen sharing, etc. If you go to blog.chiffers.com/TeamsFest, I've linked the article there that you can read through in your own time, plus all of the other articles that I'll talk about today in this session. blog.chiffers.com/TeamsFest, so you can see that for yourself. But to give you an idea, if the average round trip time is above 500, you're going to start experiencing, you're going to get that poor warning. Same with jitter as well. Above 30 or 0.1% packet loss, you're going to start seeing that flag. Now, those of you that attended Ignite potentially would have seen this demo that was performed at night. This actually blew me away. What I'm going to do is I'm going to play you 2 audio clips. What this demonstrates is up to 50% packet loss experienced during a Teams call. Now, this is very typical because Microsoft engineers and the guys that work on the back end of Office 365 have said that they often see up to 50% packet loss when calls are being made across the cellular network. So from your mobile phone, not on Wi-Fi, but when you're walking around the streets on a Teams call using 3G or 4G, right? So the aim with Teams is to deliver crystal clear audio, even in networks with 50% packet loss. I'm going to play this first clip for you a moment. This is using the current code with Microsoft Teams that's in production today. Have a listen to this.
Meeting over a Wi-Fi connection. Packets can adversely affect the call experience. In this config network to induce a burst of 300 milliseconds every 100 seconds, corresponding to 50% packet loss.
So that sounded awful, right? Like, I'm pretty sure most of you probably wouldn't be able to figure out what that person was saying. So that's up to 50% packet loss. Really, really terrible experience. You're going to have to ask the person to repeat what they're saying. Now, have a listen to this. This is what the engineers at Microsoft are working on within the back end of Teams to update the code to deal with that up to 50% packet loss.
Over a poor Wi-Fi or cellular connection, High packet loss can adversely affect the call experience. In this demo, we have configured the network to induce a burst loss of 300 milliseconds every 600 milliseconds, corresponding to 50% packet loss.
Now, I was playing that out of my Poly Alara, which is sort of sat on the desk down here over Bluetooth. But you get the idea, right? The Teams is able, with that new code, able to handle that up to 50% packet loss, which is, quite frankly, amazing. I was very, very, very impressed with that. If you want to see the entire presentation that was done that talks about this packet loss resiliency, go to that link, blog.chiffers.com/teamsfest. I'll have it at the end as well, just in case you didn't make a note of it. And I've linked this particular talk. Very, very fascinating. Of course, I experience this one all the time at home. I'll be walking around the house on my mobile phone, joined to a Teams meeting on Wi-Fi. I'll step outside, forgetting that my Wi-Fi doesn't cover outside, and my phone will switch to 4G. So Teams has been designed from the ground up to handle that handoff and roaming between Wi-Fi and cellular networks seamlessly. You may only notice maybe 1 or 2 seconds of delay when switching between those networks. Sometimes you may even notice 0 delay. The other day I was on a Teams call. I wandered up the street to the vet. It's at the end of my street here, just to get some more cat food. And I forgot that I was leaving a Wi-Fi zone. I just carried on walking. The stream didn't drop. It switched from Wi-Fi to LTE, no problems whatsoever. So highly, highly impressive. And of course, if things get so bad in the Teams client that you can no longer hear anything, or Teams can no longer connect to the Teams servers across the internet, maybe your Wi-Fi has dropped, maybe you've stepped into a black zone, maybe you're using Vodafone here in Australia. Shouldn't say that. The Teams will prompt you and say, hey, we've detected the problem here. To get around this immediately, all you need to do is tap that number and you'll be instantly connected back to the meeting with audio conferencing. Now, of course, this does require the audio conferencing license, but having the ability to do that one-touch dial from both laptops and your mobile phones is really, really powerful. Users no longer have to screw around looking for the invite, looking for the phone number. What was the conference ID? Bang, they're in. If you tap that number as well and wait a few moments, your phone will automatically enter the conference ID as you dial in as well. So you don't even need to type the conference ID. Really, really cool set of features. If we don't have any questions on that side of things, I just want to move on to testing your network and how you make sure that your network is ready for Microsoft Teams. Now, hopefully, all of you out there have already gone out and tested your network prior to rolling out Microsoft Teams. Of course, I know we all live in the real world. That's not really how it works. We roll the technology out and then we deal with the problems as they occur, right? But let's see if we can nut this one out at least. Now, some of you or most of you have probably already seen this, but this is the Microsoft Network Assessment Tool. It's actually called the Skype for Business Network Assessment Tool, but it does the same thing with Microsoft Teams. And this tool will allow you to test your connectivity and performance to the Office 365 Edge services. Why do we want to do that? Well, we want to know from a laptop that sits in our office on Wi-Fi during lunchtime when everyone's browsing YouTube, etc., how a Teams call will perform. Same thing at 9 a.m. So the idea with this tool is you set it up and you run it at different times of the day within your environment from different locations to test to make sure that your network is up to scratch and up to the ability to handle Teams. Really, really handy tool as well to troubleshoot end user problems. So if you've got an end user that's having a problem with Microsoft Teams on their home PC, run this tool on their home PC. Check out what their connectivity is like. Make sure that their router's not performing any stepping in with a firewall and blocking any traffic. It's 7:30 here, so I'm having a gin. 7:30 in the evening, I should say, not AM. So this tool, as I said, will also report any connectivity problems between your machine and Office 365, and it will say, hey, we're unable to connect to these IP addresses. You're going to need to go ahead and check that. Once you've run the test, you can run the results analyzer tool that will give you all of the results that have been collected and will give you a pass or fail. What you want to see is pass. Sounds self-explanatory. If you see any failures, you're going to have to go in and have a look at your network to figure out what's causing those failures. Failures are bad. Failures mean drop Teams calls, poor audio experience. You don't want failures. I agree. Gin is acceptable anytime, Madeline. Just not at 7:30 in the morning. Gin and cornflakes, not so good. Wouldn't recommend that. But gin and lemon with some ice, yeah, highly recommended. Very much so. All right, quality of service. Most of you know what QoS means, but if you don't, QoS is a way of controlling and managing resources across the network by prioritizing specific types of data. Now, why do you want to do that, right? Well, in the top example, you can see that you've got normal traffic, which is your maybe emails, web browsing traffic. You got your entertainment traffic, which is your Netflix, your Xbox, your YouTube, and then your critical traffic, which is your real-time voice and media traffic, right, or transactional data. And you can see that without QoS, it's very possible for your entertainment traffic, your YouTube streams and your ABC or your BBC videos or whatever you're watching, to congest your network and cause problems for your real-time audio and media, which isn't great. I mean, YouTube has its place, right? But if the board of directors are trying to run a board meeting and they can't because, you know, Karen in accounts is watching YouTube videos, that's not a good thing. So instead, we want to prioritize this traffic and we want to say, hey, our entertainment traffic, it has its place, but we need to knock it down the queue a little bit. We need to prioritize our critical traffic over it. And that's where QoS comes in. So if you're not familiar, and I'm not a network engineer, like full disclosure, definitely not a network engineer. So if this is from a very high level point of view, what we want to do is we want to prioritize our audio traffic over everything else. We want to add that to the priority queue. Of course, video traffic is vitally important as well. Probably not as important as audio traffic because at the end of the day, phone calls are probably more important than video calls. So we make sure that audio and video are prioritized as we see here. Other traffic, web, email, file transfers, etc. Of course, least not as important to arrive as quickly as possible. The thing about real-time audio and media is if it experiences any jitter or delay, it's really noticeable. If you hit send on an email and it takes another 5 seconds to get delivered, no one's going to probably notice, right? Unless you're one of those people that hits send and immediately stands up and walks over to your colleague's desk and say, hey, I just sent you an email, and then 5 seconds later it arrives. If you do that, by the way, shame on you. Send them a Teams message. So how does Teams classify this traffic? Well, it uses the DSCP value system. So by default, Teams will utilize these following ports: 50,000, 50,019, 50,019, etc. You can see the rest on the screen there. And audio traffic is always assigned the DSCP value of 46 with expedited forwarding. Now, most networks, if they've had just a base configuration with QoS turned on, will always prioritize EF as number one, top of the queue. Below that, you've got your AF41 for video and AF21 for your application and screen sharing. Few things to point out here, though, if you're configuring this in your environment. Macs, or Apple Macs, will hard code the audio and video as EF and AF41. You cannot change that. That's hard coded into the OS. You can adjust these port ranges, and I'll show you how to do that in a moment, but they cannot overlap, and they should, where possible, be adjacent to each other. Now, if you've rolled out Skype for Business in your environment previously, Teams will respect those settings and tags that you've created already, including your port ranges. And if you are using application name tagging via group policy, very important that you add the teams.exe file as a name to the policy so that group policy correctly picks that up and applies it. You can change those QoS details and ports within the Teams admin center. All you need to do is go to portal.office.com, sign in, Teams admin center, under meetings, expand message meeting settings, and just make sure that you've turned on the insert quals markers for real-time traffic. And if you want, you can specify your port ranges as well. By default, leaving them at 20 is perfectly fine. If you want to, you can automatically enable or use different ports if you wish. I highly recommend keeping with the defaults there, if possible. Once you have enabled it, you probably want to test to make sure it's working. So you can do that using the Microsoft Network Monitor tool. If you've not downloaded that before, I highly recommend that you go and grab a copy of it. Literally just search Microsoft Network Monitor tool. Download it. Here's how you configure it to make sure that QoS is being properly applied within the environment. So we can see there from the packet capture that DSCP 46 is being set for our voice workload. So we know that QoS is working in that environment. Now, a few things to keep in mind with QoS. As I said before, the shortest path to Office 365 is the best. Don't introduce obstacles and hops and proxy servers and firewalls, etc., where you can. Those things create additional latency and additional problems. If you do choose to close ports, the only thing that will happen is it will lead to a quality degradation in Teams calls. So please don't do that. And where possible, try and limit the number of hops between you and the Microsoft network. You can test that from your PC right now. Just run a trace route to teams.microsoft.com, count how many hops until you get to network.msn.net or very similar Microsoft point of presence in your country. If it's more than 5, you probably should change your ISP or maybe check to make sure your traffic's not being routed via a corporate network or elsewhere. All right, we'll move on in the interest of time. Just touching very briefly on Teams live events. Leave a message in the chat there if you do currently use Team live events today. I've run a couple of them. They're really, really useful for town hall style meetings or meetings that have above that 250 limit. One thing to point out though is that if you are thinking of using Teams live events in your environment, make sure that you have a look at using a third-party CDN or content delivery network provider. Those 3 on the right-hand side here are listed. So Collective, Hive, and Ramp. They're the 3 that are available today. What they do is instead of every single user that connects to a live event in your environment pulling down a copy of the meeting, they will pull one copy down and distribute it using agents on your internal network. So rather than flooding your internet connection, it will just utilize your existing internal network and just pull one copy of that presentation down, or 2 or 3, depending on how dispersed your network is. All right, on to reviewing Teams reports. So let's just drop out of here a moment. Of course, I've been signed out of my my Teams session here, so I'll just sign back in a moment. And hopefully everyone out there is using two-factor auth on their account. I know some of you have probably set up the Microsoft Authenticator, although I currently haven't. So I'm currently using two-factor auth still on my account. I'm just waiting for that that SMS to come in. There it is. All right, so I'm going to jump into the admin center. And we're going to go into the Teams admin center here. Now, hopefully everyone on the call is familiar with the Teams admin center. It's practically where I live these days in Office 365. We're going to have a look at user reports. So, for example, you've just received a call from the help desk who said, hey, Joe Blogs just reported that they had a poor call experience on a call a moment ago. Can you go and investigate? Now, the first thing you're going to do is you're going to jump into the admin center. You're going to go to users. You're going to find the user in question that was having a problem. Now, I'm going to use myself as a demo user. So we can see here, just as a snapshot, my 7-day call quality. I had a few calls there that had poor call quality. The remainder was pretty good though. So if I jump into call history, once this loads, I can see a number of different calls that happened within my environment, who they happened with, and again, in terms of audio quality, what teams thought if the call was poor, if the call was good, for example. So let's have a look at this one. This one was reported as poor, so we'll just expand this out a moment and see what teams is reporting for this call. So first of all, we can see here the number of people that were connected into the call. You'll notice that mobile numbers and phone numbers are hashed out for security purposes. People's names are still shown. Those of you that wonder what unknown means, that means that's an external participant. So external participants' names won't appear here. But we can see here that one of our external participants was having a problem. They were experiencing poor audio quality. So let's delve into that a little bit further and see what Teams has to say about this. So we've got poor call quality was caused by the network. So if we scroll down here, we can see some stats about the actual call itself.
So a short question, if it's okay. Is it possible to find the actual conversation through the invitation link? Because we have people telling us that they had a bad meeting at 10, then we figured out time zones, then we figured out that it was 10 after 10. So finding the actual conversation in the admin center was really hard.
Not currently, no. You'd have to scroll through the list and figure out the time zone itself. But the time zone is shown in the list there itself. But yes, I appreciate what you're saying. But yeah, you'll have to find it within the list there. So we can see here that the average round trip time for this user's call between it and Office 365 was horrendously bad. So probably using a poor network or 3G or 4G or cellular, something like that. That was the reason why that user had a poor experience there. So really handy to dive in and figure out what exactly is causing the problem. Say, for example, it's an audio device that's causing a problem. You'll see flags raised here about capture not functioning event ratio. If that's higher than sort of 0.01%, you know that the device that the user was using was experiencing problems. So keep that in mind as well. All right. Just skip over this slide. Now, one of the other things to take note is the call quality dashboard within Office 365 too. So in the interest of time, I won't sign into this because I've only got a few minutes left at the end of this session, but I'll just play this video that I captured earlier. Two areas of importance with the call quality dashboard. You want to look at the reliability reports first of all. These will show you the amount of traffic that's been blocked by your firewall. As you can see here, that number's 0 for all calls made within our environment itself, which is great. You don't want to see any of those calls being blocked by firewalls. We've also got video-based screen sharing as well. Again, 0. And you've got app sharing reports here as well, which also shows 0 too, which is great. So that's what you want to see within your environment. So if people are reporting problems, go check out that report, first of all, within the call quality dashboard. To access the call quality dashboard, the easiest thing to do is go to cqd.teams.microsoft.com, sign in there. You'll have access to all of that data. Now, one of the other reports that you probably want to look at as well is the quality of experience reports, which you can select from the top up here. This will show you a whole variety of different things, including issues that have been reported by users at the end of a Teams call when I asked them what the call quality was like. So one thing to note is those yellow lines, they look quite high, but they're actually in the 0.5 to 2% range for call quality issues. So just keep that in mind and make sure you're using the right scale on those pages there. Another thing here to check is to make sure that calls, where possible, are not traversing a HTTP proxy. You want to see no data available there where possible. If you do see calls there, you know that those calls are going via a proxy server, which is something that you probably want to address. All right, I'll hold questions until the end for the moment, just in the interest of time. Now, advice for remote workers. We are obviously living in an interesting time at the moment. So I thought it'd be a good idea to give you some solid advice for how to deal with remote workers. And I really want to give you 3 tips. The first one is, as I said previously, do not force users' traffic through your company VPN and internet. Make sure the user's traffic is leaving their laptop and using their internet connection to access Office 365. Cannot stress that one enough. Secondly, make sure your users are trained in how to use Teams, and make sure they know what to do when things go wrong as well, because things will go wrong, especially the service is under such pressure at the moment with all these multiple millions of additional people using it, right? So make sure they understand how to dial into a meeting if their Wi-Fi falls over. Make sure they understand how to switch between hotspotting from their mobile phone and the internal Wi-Fi that they're using at home. And remind them to watch out for peak time. So that could be, 9-hour time. So 9 a.m., 10 a.m., 11 a.m., 1 p.m., 2 p.m., 3 p.m., etc. Most meetings are booked on the hour. So where possible, remind users and say, hey, you may experience issues potentially connecting to meetings dead on the hour. Maybe connect a few minutes prior just to make sure that you're able to dial in. And thirdly, make sure they're using certified devices. Please make sure they're using certified devices. They're going to have a much, much better experience with Microsoft Teams if they're using certified devices. There's a giant list of certified devices. You can access that list at blog.chiffers.com/TeamsFest. The ones on the left there are MTR devices. The ones that your users are probably going to be focusing on are the personal ones in the middle of the screen here. So you got the Alara, you got the Jabra Evolve 65Ts, and the Plantronics Blackwire 7225. Really, really good devices. Also these speakerphones as well. I'm using one of those speakerphones at the moment to do this presentation. Highly, highly recommend them. And lastly, really important that we don't forget about user adoption. So I talk about this a lot within my sessions, but ensuring that your users have been trained properly, ensuring that Teams has been a top-down project, making sure it has the right sponsorship from the right people, really, really important, first of all. Getting that communication out there and training users on how this stuff works, making them aware of what's changing, when it's changing, and why it's changing, and right now how rapidly things are changing. Really, really, really important. Make sure they're using the right technology, the right headsets, the right handsets, the right devices. Really important. Don't forget to train your users as well. Now, right now, that's really difficult to do that because the majority of them are already working remotely. But organize Teams training sessions over Teams. Guide people on how to connect. Show them how to use Microsoft Teams. Get them out of email. Send them one-page A4 instructions, but don't just do that. Make sure you follow that up with live Teams training so that these people feel comfortable. And lastly, remember to support your support staff. Vitally important, right? Your support staff are the people that will answer the phone when this user has a problem or this person has a problem. That's the first person they're going to call. And if your support person answers the phone and says, what is Teams? How's that going to make your end users feel, right? So make sure your support people are trained and understand how to troubleshoot those common problems. Show them that admin center dashboard. Show them the call quality dashboard. Show them how to use those tools to effectively troubleshoot problems with headsets, handsets, and jitter on the network. They'll thank you for it. Of course, if all that fails, just send everyone a cake, right? Or everyone can access links to the presentation today by going to blog.chiffers.com/TeamsFest. I will be uploading a copy of this presentation to there probably within the next 10-15 minutes or so. So you'll be able to access all of these slides from there. A recording of this session will be available within the coming days or weeks after this on the team. Anyone have any questions in the last few minutes? I saw a few come in before. Just scrolling back up through the chat list a second. Okay, so does Teams live events support guests and federated users as presenters? Yeah, so currently, as far as my understanding, or from my initial testing, you can send a presenter link to a person outside of your organization. From my initial testing, I don't use live events that much, so that may be wrong, but yeah, I believe that's what I've tested. All right, if no one else has any further questions, please do remember to leave feedback. Get your phones out and open your camera app on your phone and scan that QR code on the screen there, or just browse to bit.ly/2VHQFZG. Try to remember that. That's a bit of a mouthful, isn't it? Scroll down, you'll find my session name, Craig Chiffers. Please do leave feedback, good or bad. Always looking to improve. Now, coming up next in this room is Martin, who's talking about getting Skype Sit done. Love that. Do stick around if you want to move from Skype for Business to Teams. Up in room 1, Magnus is talking about Microsoft Teams is only part of an implementation of Teams. Very true. Room 3, we're doing a deep dive with Microsoft Teams integration with SharePoint. And in room 4, we've got the Microsoft Graph fundamentals, which might be something that I'm going to go take a look at. Thank you very, very much, everyone, for joining. Enjoy the rest of your day, or night, or morning. Thanks, guys.